Hello everyone, today let's solve the problem power tree, right? So this was asked in the Codeforces round 543 division 1 based on the Technocup 2019 final round, right? So this is fine. So you can just go through the question. It's easier to understand. Let me summarize the question so that it will be easier for us to solve the problem, right? So let's see what the question states now. Just give me a second, 1 second here. Yep, just give me a second, 1 second. Yeah, so we have a rooted tree, right? So we have a rooted tree. Let me write here root equals 1, right? So we have a rooted tree that is root equals 1 with non-negative vertex prices, right? So with non-negative vertex prices, right? A guy named Arkady buys some vertices, means pays their prices basically, right? Then Vasily sets arbitrary integers on every leaf, and finally Arkady may add arbitrary integers to all the leaves in the subtree of any bought vertex just to try to make all the leaf values 0, right? So again, I'll just read this one out loud. Just remember, just try to listen to this carefully. So we have a rooted tree that is initially root equals 1 with a non-negative vertex prices, right? So a guy named Arkady first buys some vertices, then a guy named Vasily sets arbitrary integers on every leaf, and finally Arkady may add arbitrary integers to all the leaves in the subtree of any bought vertex, right? To try to make all the leaf values 0. So then what we need to do here, we need to find the minimum total cost, right? So what we need to find here, minimum total cost, right? So we need to find minimum total cost S basically, right? So we need to find minimum total cost S that guarantees Arkady can make every leaf 0, right? So that guarantees Arkady, a guy named Arkady here, can make every leaf 0, right? Can make every leaf 0 no matter Vasily's choices, right? So and we have to list all the vertices that appear on at least one optimal right? Cost equals S by Z, right? So this is fine. This is the question basically, right? So let me read out the question loudly. So we have a rooted tree, root equals 1 with non-negative vertex prices, and Arkady first buys some vertices, sets the arbitrary integers on every leaf, and finally Arkady may add this one arbitrary integers to all the leaves in the subtree of any bought vertex to try to make all the leaf values 0. So what we need to find here, we need to find the minimum total cost S here, this one, that guarantees Arkady can make every leaf 0. Arkady can make every leaf 0 no matter Vasily's choices, and we have to list all the vertices that appear in at least one optimal cost equals S by Z, right? So just remember this one, right? So this is the question, right? So let me come to the input output part here, right? So we have been given here n equals 5. See here, this one, right? So this one we have been given 5 1 3 2 1 as n equals 5, and we have been given vertex, this one, edges, right? So 1 to 2, 2 to 3, this one 2 to 4, and 1 to 5, right? So this is fine. The output that we need to get here is basically 4, right? So this will be represented in the format 4 3 2 4 5, right? So basically the output will be 4. This will be represented as 4 3 2 4 5. This is fine. Same goes with the second example as well, man, right? So now we have the understanding of the question. Let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code, right? So first of all, I just want to discuss certain points, and then let's consider the first example, right? So first thing is, we will be going with a DP approach, right? So we'll be going with a dynamic programming approach. So let's discuss the key idea. Nothing but the DP states, right? For each node u, we have to compute two values here. One thing is here, we will be going with dp of u 0. Also we will be going with dp of u and 1, right? So this will be dp of u 0, and this will be dp of u1, right? So so we are going with a concise dp approach here, right? So key idea, nothing but the DP states. Let's discuss the key idea here. Nothing but the DP states. For each node u, we have to compute two values. One is DP of u0 and another one is DP of u1. So what is this DP of u0 basically? So this is the minimum cost to ensure all the leaves in use subtree can be zeroed if use parent does not help. Right? If use parent does not help. Right? So what is DP of u1 here? DP of u1 is nothing but minimum cost to ensure the subtree can be zeroed if use parent does help. So use parent, this one here, use parent doesn't help, right? So let me write here, doesn't help, right? So this is fine, I believe, right? Use parent doesn't help. So this one, use parent does help. Use parent does help here. This is fine. So we have two states here, DP of u0 and DP of u1. So we'll be maintaining two states. One is DP of u0 is nothing but the minimum cost to ensure all the leaves in use subtree that can be zeroed if use parent does not help, and DP of u1 is nothing but minimum cost to ensure the subtree can be zeroed if use parent does help, right? So these are the two things, two states. So let's go with the base for the leaf L, right? So let's go with the base for the leaf L. So yep, let's go with the base for the leaf L here. Let's go with the base for leaf L. This is fine. Now we will be going with two things. One is DP of L0 and another one is DP of L1. So let me write it over here, this one. So we will be going with DP of L0 and also we will be going with DP of L1. So let me go with here, DP of L1. This is fine. So DP of L0 is nothing but the weight of L. Weight of L is if parent won't help, we must buy this one L. If parent won't help, we must buy L, this one, DP of L0. What is DP of L1? So this will be equivalent to the 0 basically. So this will be equivalent to the weight of L. This one, DP of L0 will be equivalent to the weight of L, and DP of L1, this will be equivalent to 0 because if parent helps, no cost inside L at all, right? So we can just go with the 0 here in this case, right? So this is fine. Now what we will do, we will be let me show you the transition at the internal node u here, right? So internal node u in the sense child v, right? Children v basically, right? So let's discuss the transition at the internal node u or the children v here. So we will be going with the sum child 0 equals sigma of dp v0. See here, child this one. So this is nothing but the variable name. So I'll just go with here sum child equals, I can just represent in this way, sigma. So this one dp of v0, dp of v0. This is fine over children, right? So if parent doesn't help you, then we can just consider dp of u0 either every child handles itself, nothing but some child 0, right? So this one itself. So we'll be going with, this is some child 0 1, right? So some child 0, I'll just write sc0 here, right? So if parent doesn't help you, then either every child handles itself, some child 0, or we have to buy u and use that purchase to reduce one child to the parent helps state, right? So also we can do one more one more thing, try every child v and take the sum child 0 minus dp of v0 plus weight of u plus dp of v1, right? So just to take the minimum. So what if the parent helps? So this is for parent not helping, right? So when parent helps you, nothing but this one is for dp of u1, right? So dp of u1, right? So parent can play the helper role for you, so we can force one child to dp of v1 without paying weight of u, right? So dp of u1 equals min over v of some child 0 minus dp of v0 plus dp of v1. This one we will get to know while we write the code, right? So I don't have to this one show it in the theory format, right? So this part basically. So finally so s equals this one dp of 10, we'll be going with finally dp of 10, right? So in our case dp of 10 has to be 4, right? So we have been given 4 3 2 4 5. Here in our case we have to get output 4 for the first input I'm speaking of that I showed, right? So this one dp of 10 is nothing but root has no parent, so root is in the parent does not help situation, right? So this is fine, I believe. So let's get into the first example. Let me consider this example, this example for the approach, right? So I have explained the dp idea. Let's try to do the same thing for this particular example, right? So just so here I have considered the same first example. I've considered the same first example, right? So here we have 5 5 1 3 2 1. This one edge we have here, edges we have 1 2 2 3 2 4 and 1 5. The output that we need to get here is 4 3 2 4 5, right? So this one is fine, I believe, right? So let's move on with a step by step explanation here. Just give me a second, 1 second. Yep. This one, yeah. So first thing is we'll be going with the dynamic programming along with the DFS, right? So mainly we'll be going with the dynamic programming, sorry, not be going with the DFS, I believe. So we'll be going with the DP on trees basically, right? So step by step explanation. Let's go with the step by step explanation. We have already discussed the DP idea, right? So let's go with the step by step explanation here. So n we have here as 5 and weights we have here as 5 1 3 2 1 and edges we have been given, so the same input I'm considering, right? So leaves we have here as 3, will be considering 3 4 5 here, right? So we will be going with dp of 3 dp of 4 dp of 5 because leaves we have considered 3 4 5 here, right? So dp of 3 0 will be 3 and dp of 3 1 will be 0, right? So for the dp of 4 dp of 4 0 will be 2 and dp of 4 1 will be 0. You can just look into it. dp of 5 dp of 5 dp 5 of 0 will be 1 and dp 5 of 1 will be 0. So let's go with a node 2 here, meaning we have to consider children 3 comma 4. 3 and 4 will be considering here, right? So as I've said, we'll be going with the variable some child 0 for the children 3 and 4. This will be 3 plus 2, right? So this will be 5 and dp of dp2 of 0 will be 3 and dp2 of 1 will be 2, right? Simple. So now after considering the node 2, we'll be going with the node 1 basically. For node 1 we'll be considering the children 2 comma 5. So we'll be we'll be going with the variable some child 0, right? So this one will be dp2 of 0 plus dp5 of 0, nothing but 3 plus 1. So here in this case we have to get the output 4. For the dp1 we'll be going with the 8 and we'll be going with the try child 5, nothing but 4 minus 1 plus 5 plus 0. So this value will get 8, right? So this you can just look into it, right? So dp1 of 0 will be considering this one as the output, right? So accordingly with what we discussed, the dp idea, dp1 of 0 will be considering this one as output, right? So dp1 of 0 we have got 4 here. So dp1 of 1 we got 3 here. So final output, so dp1 of 0 will be 4. We have to display dp1 of 1 as well, right? So this one will be 4 3, right? Here this one will be 4 3 and also just remember the second line we have in the output they had mentioned 2 4 5, right? So the output that we got here is 4 3. So to recover which vertices can appear in some optimal set, the code whatever we'll be writing, that code it does the second DFS basically. So we will be making use of the DFS, I was right basically, right? So the second the code does the second DFS that traces which choice led to the optimal DP values, and also we will be marking the vertices that can be bought in some optimal plan, right? So for the example we'll be tracing and finding the vertices 2 4 5, right, for the first one, right? So overall output would be 4 3 and 2 4 5, right? 4 3 and 2 4 5. So the output that we got here is 4 3 2 4 5 which is equivalent to the output they have mentioned for the example 1 within the question. See here, right? So the output that we got here is 4 3 2 4 5 which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct. So as we are completely familiar with the approach, let's move on with the complexities part. So what will be the time complexity here? The time complexity would be big of n, right? So when I say the time complexity would be big of n, here every edge or node is processed at a constant number of times, right? So we'll be making use of one DFS to compute the DP or the dynamic programming, and another DFS, one more DFS. I said we'll be going with the 2 DFS, right? So one DFS to compute DP and one more DFS to trace the choices, right? So overall time complexity we can just consider big of n here, right? So what will be the space complexity here? The space complexity would be big of n as well, right? So here space complexity would be big of n because we'll be going with the adjacency lists, DP and the auxiliary arrays, right? So we'll be going with a degree, mark 0, mark 1 can be chosen. So these are the variables, variable name. So we can make use of anything. This is fine. So which is of the linear space basically. So overall space complexity would lead to big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively, right? So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come here. We'll be making use of the fast input and output. So let me import input output package. So I'll just go with java.io.star here, and also let's this one. Let's go with a let's import the this one utility package as well. So this will be java.util.star. This is fine. Now let's do one thing. Let's go with a main class main, right? So I'll just go with public class main. So within the main method, let's do one thing. Let's go with here static final. So int max this one n equals 2. This one we have to go with a maximum n along with a margin, right? So I'll just go with 2 followed by 4 zeros here 5 the value, right, accordingly with the constraint. Also let's go with a large number as infinity. So I'll just go with here this one also will be accordingly with the this one, what do we call, constraint. So I'll just go with long. So I'll just go with infinity equals, so this one will be long 10 to the power of 18 nothing but 1e 18 plus 7, right? So this is fine, I believe. Now let's initialize certain things, man, quickly, right? So let's go with the number of nodes. We have to go with the number of nodes. So this will be static and n. Next let's go with the price of each vertex. In this case I'll just go with static long. So this one will be weight new long of, let me pass max n. This is fine. Now let's go with the custom degree trick to detect the leaves, right? So let me go with here static int. So this one will be degree, this one will be new int of max n, right? So again now let's initialize the DP array, man. So we'll be going with a DP of u0 and DP of u1 as described, right? So within the approach, so let me initialize here static long. So this one will be DP equals new long of maximum along with the 2. This is fine. Now we have to store the this one what do we call, final answer somewhere. For that one let me go with a can be chosen, right? So this will be of the type boolean basically, static boolean. So this one will be can be chosen. So this one is fine, new boolean, this one will be maximum. This is fine. Now let's go with the helpers, right? So helpers, because we have to trace the choices, right? So for that we'll be making use of helpers basically. So I'll just go with static here again boolean. So this is fine. Let me go with mark 0. This is also fine. One will be new boolean of this one will be maxim along with, let me go with mark 1 and let me assign this one to new boolean of again let me pass max in here. This is fine. Now after going with the helpers, the final one is we have to go with the adjacency lists, right? So I'll just go with static here, this one array list. So let me go with integer This is fine. Let me go with tree equals new array list of this one will be maxim, right? So this is fine, I believe. Now let's do one thing. Let's go with the first DFS, meaning we have to compute the DP values, right? So we'll be going with the bottom up approach, right? So let's go with the DFS. So this one, let me go with the method static void, the method name DFS, and we need two parameters. One is u followed by parent. Both are of the type int, right? So this is fine. So within this method, as I've said, first thing we'll be going with the leaf detection, right? So basically by the construction and main, right? So let me write the simple if condition here. If degree of this one u, if it is equivalent to 0, then what we will do, so if the parent doesn't help, we must buy this particular leaf. So we have already discussed this one. We'll be going with dp of u0 and dp of u1. So this one will be dp of u0 equals weight of u. This is fine. Also dp of u1 this one will be 0. If parent helps, then we are going with the weight of u. If you remember this one, dp of u0, weight of l, and dp of u1 is directly 0 because here parent does help, right? So the same thing here, right? So if the parent helps, then there is no cost here. Finally, we are done. If we are done with the leaf, then I'll just give a return. We don't have to return anything. So let me give the return keyword here, right? So this is fine. Let me come out of this one entirely. Now let's do one thing. Let's go with a sum of dp of v and 0 over the children. So I can just give in this way, sum child 0. So this is the variable name I was speaking of, right? So within the approach, some child, this one 0, I have initialized this one to 0. Next let's go with the, or let's iterate adjacency. So I'll just go with the iteration part. So this one will be int v tree u, right? So within the for loop, sorry, this one has to be u, that's it. This is fine. Just give me a second here. So within the for loop, let's do one thing. We have to skip the edge back to the parent, right? So let me write the simple if condition very quickly. So if v equals parent, the value I'm speaking of, so then I'll just give continue here, continue, right? So this is fine. Now let me make use of the helper method DFS. We have already written DFS here, right? So this one DFS of v comma u, this is fine. We are just computing the child first here, right? So this is post order DFS, man. You by this time we have to know the post order. We have solved many problems on post order, pre order, and in order, right? So this is fine. So finally we have to accumulate in the sense, I'll just go with some child 0 here equals some child 0 plus dp of v and 0. This is fine. We are done with this part, man. Let me come out of this one entirely. First thing is, so we'll be going with the dp of u0 and u1, meaning first one dp of u0 is this one. So this is the option, meaning every child handles its subtree independently, right? So this one is for the dp of u0 I was speaking of. So this one will be, let me assign this one to the some child 0, right? So the next one is, so this is nothing but the initialization part, dp of u1 with the infinity. So let's minimize it. Let's try to minimize it, right? So by assigning that one to the infinity, so this one will be dp of u1. So let me go with infinity. So this is fine, man. Now let's move on with the iteration part here. So we have to try the improvements considering buying u or parent help, right? So this one will be for int v. So this one will be tree of u. This is also fine. So within the for loop, so if v equals parent, then let me go with continue. Let me go with continue, right? So this is fine. If we buy u, then we have to go with a pay weight of u, and for the child v, we can use dp of v1, right? So in the sense, I can just write here dp of u0. Again, we have to consider dp of u0 and u1, right? So if you remember the approach, so dp of u0 is nothing but the math.min of dp of u0 along with some child 0 minus dp of v, this one again 0, plus this one will be weight of u, so this is also fine, plus dp of v 1, right? So this is fine, man. dp of u 1, this is fine, so this will be math.mun of dp of u, so this one will be 1, some child 0 minus dp of v, this one will be 0, this is also fine, plus dp of v1, right? So this one will be dp of v1. Let me come out of this one entirely. Now we are done. We already have went with the first DFS, right? So now let's go with the second DFS. Why we have to go with the second DFS? We have already discussed this one, right? So we have to go with the, we have to trace which choices can lead to the optimal DP of 10 basically, right? So that will be the final output, DP of 10. So we have to trace which choices can lead to optimal DP of 10. For that we'll be going with the second DFS. So I'll just go with the static here. So this one will be void DFS. Let me give DFS trace method name again. Let's go with the parameters u and parent again. So within this method, first let's recompute the sum child 0 for node u. So I'll just go with long sum child 0. Let me initialize this one to the 0. So let me go with for loop. So this one will be int p of tree, this one u, right? So this is fine. So if v equals parent, value v, this one equals parent, then we have to skip that one. For skipping, I'll just make use of the continue keyword here. And again, some child 0 equals some child 0 plus what we get, dp of v0, right? So this is fine. Yep. So now we are done with this part, man. So next, let's go with, or let's continue with the code. So just give me a second here. 1 second. Yeah. So now let's go with one thing. Let's go with simple if condition. So if we are following the branches consistent with u being in parent does not help case, right? So we are just going with the parent does not help case. Then for that, let's write the simple if condition here. If mark 0, so this one will be mark 0 of u, so this one is fine. So within this if condition, let me go with one more if condition here. If degree of u, this is also fine. So this one, if it is equivalent to 0, this is nothing but the leaf, then let me go with can be chosen here. This one of u, let me assign this one to the value true, right? So this will be true basically, right? So this is fine. Now else what we will do, so this one will be let's initialize the count to 0. So this one will be count equals 0, and let me go with for loop in v, this one of tree u, this is fine. Now within the for loop, let's go with the if condition. So this one will be if v equals parent, so we have to skip. I'll just make use of the continue keyword here. So we have to check whether dp of u0 equals the option, right? So we have to go with by u and let v be dp of v1, right? So I can just write the if condition in this way. If dp of u0, this one, if it is equivalent to some child, this one 0, this is the variable name we have considered, right? This will be minus dp of v0 plus weight of this one u plus dp of v1, right? So dp of v1, then we have to increment count, nothing but count plus plus here. This is fine. So this is fine, man. Let me come out of this one entirely. Now if at least one child provides this one, the equality, then we can choose the u, right? So for that, let's write the if condition. If count greater than 0, then I'll just go with can be chosen of u, so let me assign this one to true, right? So this is fine, man. Also let's go with if some child 0, so this is equivalent to the dp of u 0 or count this one. If it is greater than 1, uh, then within the if condition, let's go with a simple for loop. So here if we are going with the sum child if it is equivalent to the dp of u0, right, or count if it is greater than 1. In simple terms, we can go with the either base option, nothing but every child is independent, was used earlier, right, or there are multiple children giving the same improvement as well, right? So in both the cases, all the children must be followed and mark 0, right? So for that one, let's write the for loop here for int. So this one v tree of u, this is fine. Let me go with if v not equal to parent, so this one mark 0 of v, let me assign this one to the true, right? So this is fine, man. Yep. Else so we have to go with exactly one child v, that is the special one used in the by u option, right? So this one will be for int v tree of u, right? So this is fine. So within this for loop, so let me go with a simple if condition. So this one will be if dp of u 0, if it is equal to some child 0 minus dp of v 0 again, so plus weight of u, so this one will be dp of v dp of v1, so this is fine. Mark 1 of v, this one equivalent to true, right? So this is fine. Mark 1 of v, this is equivalent to the true. Else what we need to do here, else mark 0 of v, this one, let's assign this one to the true. This is fine. Let me come out of this one entirely. Right, so now we have to go with the mark 1, man. The same steps we have to follow here. So this is fine. Let me copy these things here. So this is fine, I believe. Just give me a second here. Yeah, let me copy this one entirely and let me paste it over here and make the necessary changes. So this one will be mark 1 of u. So if degree of u not equal to 0 for this one, right? So we are considering mark 1, right? So we are just following the branches consistent with u being in parent helps, basically parent helps case. So this one mark 1 of u is nothing but the when parent is helping the case, right? Second case we are going with, right? So if degree of u not equivalent to 0, then let's do one thing. Instead of can be chosen here, so let's go with this one. What do we call? Let's initialize the count to 0. This is fine. Also let's do one thing. Let's go with the for loop here for int v of tree, this one u, this is fine. So within the if condition, so I'll just go with v equals parent. So let's go with continue keyword, right? So this is also fine, man. So let's go with the simple if condition. If dp of u 1, this is also fine, equals some child 0 minus dp of this one v 0, so this one will be dp of this one v 1, this one will be count plus plus, right? So this is fine. So let's go with the if condition instead of the else, right? So let me remove this one. So this one has to be if, basically. So let me go with if uh, when count is greater than 1. So when count is greater than 1, basically let's do one thing. So we remove this one entirely until here. So this is fine. Let me type from here, right? So count plus plus I have given, right? So this is fine. Let me go with this one here. If this one count, if it is greater than 1, then if more than one child qualifies, then all the children must be considered as this one, what do we call, mark 0, right? So let's go with a simple for loop here. So this one will be for how can we write? So this one will be int v of tree u, basically, right? So this one will be if v not equal to parent, right? So v not equal to parent, so then mark 0 of v, so let me assign this one to the true, basically, right? So this is fine. Let me assign this one to the true, right? So else what we'll do, so if there is exactly one child, that is the special one, the parent helps, then we have to mark it as mark 1. Otherwise we have to mark this one as mark 0, right? So for others, basically we have to mark with mark 0. So how can I write that one in the form of code? So this one will be for so we have, did we consider else? Yeah, within the else, let me go with the for loop. So this one will be int v of this one tree of u. This is fine. So within the for loop, so let me go with if condition dp of u. So this one will be 1, some child 0, this dp of v, so this one will be 0, dp of v 1, this is also fine. Then I'll just go with mark 1, so this one will be v, let me assign this one to the true, basically, right? So this is fine. Else what we need to do, so I'll just go with else here. So this one will be mark 0 of this one v, let me assign this one to the true. This is fine. So we are done with the coding part almost. So forgot this one, I believe. What do I call the brackets? This is fine, man. Let's continue the recursion part here. So we have to continue the recursion part, right? So let me go with here for int v of this one. You have to consider tree right here, tree of u. This is fine. So within the for loop, we are just continuing the recursion here, right? So let me write the simple if condition here. If v not equal to parent, then let's go with the dfs trace method. We have already written dfs trace method, right? So here this one we are making use of here. So this will be dfs trace of v comma u. This is fine. Now let me come out of this one entirely, right? So let me come out of this one entirely. Now we are left with the only main method, right? So this is huge again. So let's write the main method quickly. So I'll just go with main here. So this is fine. Let me remove this one and let me go with throws. So this one will be throws exception, right? So within the main method, the first thing that we need to do is let's go with the input output very quickly, right? So this one will be buffered reader br equals new buffered reader. So this one will be new input stream reader. So this one is fine. System dot m, this is fine. Now let me go with print writer. So this one will be out equals new print writer new, so this one will be buffered writer instead of buffered reader, new output stream writer of this one system dot out. So this is fine, man. Yep. Now let's do one thing. Let me go with n equals integer dot parse, so this is fine. Buffered radar dot read line, so this one is fine. Dot trim, so we have to trim the white spaces, so I'll just make use of the trim here. This is fine, man. So we are just reading the n, right? So the first line, whatever we have been given, in our case it was 5, I believe, right? So this part, yep, we have to read the n basically first. Next, after reading the n, we have to read the weight as string. See here, the weights 5 1 3 2 1, this one we have to read, right? So I'll just go with the string here. So this one, let me consider w array, weight array, right? So buffered reader dot again read line, let me go with split here, right? So split, we need space, right? So within the integers, between the integers basically, right? So we have to read weights as strings. Next, let me go with the for loop quickly. So this one will be int I equals 1, I less than or equal to n, I plus plus, right? So within the for loop, what we'll be doing, first thing is we have to pass the long wait for the node I, nothing but, so I'll just come here. So this one will be weight of I equals long, sorry, so this one has to be capital L, long, so let me go with a parse long here, right? So this is fine as we are considering long here. So this one will be weight array that we considered, weight array of previous value, nothing but I minus 1. This is fine, man. We are just passing the long wait for the node I, right? So next, let's initialize the degree trick. Basically, when I say degree trick, it is nothing but the decrement. So non-root leaves end with the 0 here, right? So I just have to go with degree of I minus minus decrement, right? So this is fine. Next, let's go with the initialization of the adjacency for I. So I'll just go with tree of I. Yeah, this is fine. So this one will be new array list. This is fine, man, right? So this is fine. So I'll just come out of this one entirely now. So we have to adjust the root. So root isn't considered a leaf by the trick. So I'll just go with here degree of this one. What do we call 1? We have to increment this time, right? So yeah, we have successfully adjusted the root. So root isn't considered a leaf by the trick, right? So whatever the trick that we are doing, so this is fine. Now let's go with a simple for loop, right? So we have to go with the iteration, right? So this one will be int I equals 0, not ui basically, it's just I, int I equals 0, I less than n minus 1, I plus plus. So this is fine. So within the for loop, what we'll be doing, I'll just go with the string here. So this one will be parts, just give me a second here, parts. So this one will be buffered reader dot read line, this is also fine, dot split. Yep, yep, we are done with this, right? So we have just read the edge. So int u equals, so this one will be integer dot percent, so this one will be parts of 0, right? So this is fine. So this one will be int v equals integer dot percent again, so this one will be parts of 1, right? So this is fine, man. Now let's go with the undirected tree adjacency, right? So this one will be tree of u dot this one add of v, right? So this is fine. Nothing but the undirected tree adjacency. Now let's go with tree of v, this is fine, dot add of this one u, right? So this is also fine. Now let's increment the degree that counts. Basically this is combined with the earlier decrement trick that we did, right? So this one we have to go with degree of u and degree of v plus plus, nothing but increment, right? So this one will be degree of u plus plus, also degree of v plus plus, right? So this one will be degree of v plus plus, right? So this is fine, man. Let me come out of this one entirely. Now first we'll be going with the corner case. We have the two corner cases, right? So when n equals 1 and when n equals 2. So if n equals 1, then what I'll do, So within this if condition, so we have to go with out dot println. So what we need to print here, so I'll just go with a weight of 1. Also let me go with 1 here, so this one will be 1. This is fine. Now again I'll just go with out dot println. So we just have to print 1, right? So this time now we need to flush the output, so I'll just go with flush, or you can just go with flush or close. I'll just go with flush, and also we don't have to return anything. I'll just mention the keyword return here. This is fine. Let me come out of this one entirely. So let's copy the same thing when n equals 2 basically, right? So I'll just come here. Let me copy the same thing. So if n equals to 2, then we have to print weight of so this one remains here. This one has to be weight of 2 plus this one 1. This is fine. So here we have to change this one to the 2 within the strings. Again we have to flush the output, and let me go with the return. This is fine, man. So now we have already written this one DFS helper method, right? So this one, so we'll be making use of this first DFS helper method within the main method. So I'll just come here. So let me give DFS of this one 1 comma 0, right? So we are just computing the DP from the root. This is fine. Now let's go with the minimal cost as nothing but when root has no parent, then we have to use the DP of root 0, right? So I'll just go with out here dot println. We don't need ln, right? So we have to print that one in the same line. So this one will be DP of 1 0 plus, so let me leave the space over here, right? So this is fine, man. Next let's do one thing. Let's start tracing from root in the parent doesn't help case. So this one will be mark 0 of 1. Let me assign this one to the true, right? So let me assign this one to the boolean value true basically, right? So this is fine. Next is so we have to mark the vertices that can be chosen on any optimal solution as well. For that one we have written one more helper method named DFS trace here, this one, right? Second DFS basically in simple terms, right? So I'll just come here. Let me give DFS trace of we have to pass 1 comma 0. So we are just marking the vertices that can be chosen in any optimal solution, right? So this is fine, man. Now we are left with only certain things. We need the count, so I'll initialize the count to 0. So let's go with the iteration. So we have to count them, right? So in simple terms I'll just go with int I equals 0. So we have to start with 1, sorry, right? So I less than or equal to n, so this one will be I plus plus. So let's write the simple if condition. If, let me go with can be chosen here, this is fine, within the I, right? So this is fine. Then we have to increment count plus plus. So this is fine, I believe. After counting them we have to print the count. So for printing the count, again I'll just go with int println, and let me pass count, right? CNT here. This is fine. We are just printing the count. The next step what we'll be doing, so we will be going with a for loop. So this one will be int I equals 1 I less than or equal to n. So this one will be I plus plus, right? So if can be chosen of I, so this one is fine. I'll just go with out dot println. So this one will be fine, out dot print. So this one will be plus this is fine. Yeah, let's leave the space. So basically this print in this one indices and this one increasing order, right? So as we know this one, sorry. So finally we are left with only one thing, meaning we have to flush the output. So I'll just go with out dot flush here, right? So you can just go with flush or close. I'll just go with a flush here. So we are done with the coding parts. This is for the coding, right? So this is it for the coding. So before this one, checking the code with different inputs, let me copy paste the signature starter template here. So I'll come here. Yep, let me paste this one. This is fine. Yeah, I'll just come to the question. Let me copy this one entirely. We have to get the output 4324 245, right? Let's check the same. So I hope, oh, we have many errors, man. 30 errors. Wow. So here static long, what error we have? incompatible types long cannot be converted to the long, single array, double array. So line number 29 here. So we are going with the DP array, right? So DP array. So I have mentioned the single array here. Yeah, we are going with max and 1. So this error has to be gone now. So yeah, now 29 errors are gone with the same thing. We are left with only one error. Basically, what's the error? So this is the warning. Basically, let's ignore this one. Let's come to this part. Cannot find the symbol. So I have just given here g dot pass long. So here g, there is nothing called g man. Somewhere I have missed something. 118. So this one, what we are considering here within the main method, right? So just give me so this is fine. So what we are doing here, 1 second. 119, I completely missed it. This one, right? 118 basically. Yep, line number 118. Yep. So this one has to be weight of I have considered. So we are just passing the long weight for the node I, right? So this one has to be long actually. Why did I give this one G? I don't know. This one has to be long, not parse long as well. This L has to be capital. This is fine. Yep. Now let me run this one again. So yeah, 43245, we are getting the correct output, right? So let's ignore the this one warning. So let me come here. Let's go with the second input. We have to get 23123, right? So let me run this one. Yep, 23123, we are getting the correct output right here. So this is fine. Now this works correctly for the two inputs that they have mentioned in the question. Basically, let me copy this one entirely. Let me hit the submit button. Let me paste this one, right? So let me hit the submit button. So this is literally the hard one, man. This is extremely hard one. I'm not gonna lie. This is extremely hard. Even though this is 1120D, this question is extremely hard. So basically this was asked from the 543 within the division 1, right? So based on the Technocup 2019 final. So this is the hard question. So here you can clearly see. Yep, whatever the code that we have written is working correctly, right? So this is fine. Let's wait for some time. So here you can clearly see the verdict that we got here is accepted along with this one. What do we call toast? In the toast also it is showing accepted, right? So we have made use of the pure DP here along with the DFS, two DFS, right? So we have went with the two DFS. One is DFS and another one is DFS trace, I think, helper method, two DFS. We are making use of the DFS twice and we are going with a DP, right? So DP on trees basically, right? So this is fine, I believe. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.